I want to tell you about what we think about electronics design in the context of embedded vision and vision applications. The fast lane to vision, the topic is, of course, that is fast, and how do we reach that? Modular design is one of the possibilities to speed up design. So maybe some of the topics that I explained today are not brand new for you. Maybe you had some of these ideas too, or are already acting like this. So it would be interesting. You have the option to ask questions after my talk. So to see what are you already thinking or doing in that direction to speed up project management. My name is Oliver Hälzle. I'm the CEO of HEMA Electronics. We are a family-run business with 46 years on our history line. So, to get a rough idea about HEMA Electronics, we do hardware, software design and production of electronics, of hardware, FPGA-based video management. So, we do engineering. That's okay, many of you do the engineering, software development. What makes the difference about HEMA are 3 points that I want to point out on you. Is the focus on embedded vision video management. So for all of you, you know the video systems, you have sensors, you have cameras on the one side, you have a kind of processing unit, might be an industrial PC, might be a FPGA, GPU-based system, and on the other hand, you have displays or, in the future, technical systems with more or less AI to get the results and to handle these results and do whatever automation or other application is needed. So we focus on the embedded vision. So the next point that makes the difference is that we do the design, production, and product lifecycle management. So we care for the whole project. And the third one is, and that's the topic of today, we have built a platform to make it reusable, so to speed up design and to save on our resources on engineers. So maybe you will see in this slide that you know the situation. Yeah. Daily life of engineers, it's typical at our company too. We are not different than our customers or partners. All the projects that you are integrated part of the team, you have stress, you have frustration, you have long working days because the project started too late. That's typical. And who has to do the final engineering task in the last couple of days or nights? Yeah, you began too late. You have to run for your life to solve the task at the end. It's the engineers. Yeah, on the last day. And the next project, it's the same. You didn't learn, or the organization didn't learn because it starts too late again, and you have to run at the end. Yeah? And you are not really happy. So what do we do with these results that we see for many, many years in our history with our projects and our company projects? And when you are proud to reach the results at the end, somehow is meant by out of time, out of budget, and out of your own expectations because it went not as you would like to have it. It was not agile, it was not flexible. So this is the situation on project management that we face often. Yeah? Maybe at your projects too, sometimes at ours, yes, it is like this. So when we have a design project, when we design electronics, embedded vision electronics to support a sensor system, a whole automation system, we have several possibilities to design the system. Often we can pick a component from the shelf. We can use an industrial PC, we can buy a component, an accelerator card, We can use a server infrastructure from HP, a whole rack, something like that. We can buy the components. On the other hand, we can build them from scratch. So if you don't have a component available, you can build it from scratch. Nice project. It's where the heart of the engineers is really belonging to, because we can deep dive into technology. Yeah, great feeling, great task, great topic. But you have to do it every time, again and again. And one of our ideas was, how can we modularize it and not do it again every time? So how can we modularize it, scale it, build building blocks out of these recurring tasks that we have? Because when we have video inputs from cameras, we have all of these projects have more or less the same kind of video inputs. So we repeat and repeat and repeat the tasks. So how not modularize it and make this easier? So to give you an idea what we think about a possible solution, that's what I meant about maybe you have the same ideas and you will find the same ideas, or you find some new ideas, or afterwards you have some ideas that would fit to our model. So we have the idea to explain how we handle these tasks. So we have defined 3 levels of technology in these kind of projects. Of course, we have hardware. We need a hardware, we need a PCB, we need a processing unit. Could be an FPGA, could be a GPU, and a smaller or bigger one, hardware level PCB. We have a second layer where we have all this IP core application driver level of software to have an image pipeline, or we have drivers for Bluetooth because we want to have a wireless transportation of our data. And the third layer is the application layer, where all these AI applications are running, where the algorithms are running, neural networks and stuff that are in these layers. That is the first step to separate the different tasks and to talk with the customers who's responsible for what kind of tasks and applications. So you get a rough idea to have several layers. So in this slide, you see some more details. You will recognize the interfaces. I hope you can see the smaller ones. Yeah, looks big enough. Typical interfaces, storage, processing, power management. That are the tasks that you, when you look at your different projects, repeat and build in more or less the same kind every time in your project. On the second level, IP cores, signal processing. You have to handle the video streaming, compression, image upgrade, image processing. It's repeatable often. Maybe there is a bigger change in these kind, on this level. It's a bit different, but there is a lot of tasks that you repeat again and again. Of course, there is already mentioned the topic of IP cores, that you can buy some of these applications already. Software application level layer 3, yeah. That's what we focus less, because that's customer specific, and mainly that's the key competence of our customers. So we build on level 1 the video units, the hardware, on level 2 the IP cores, and application is mostly done by our customers. Oh, how does that look like in the next step? So we have 45 plus modules, we call it building blocks in software and hardware. And it's, if you make just a list of it, you said, okay, what will happen in a video unit? We have camera inputs like an SDI or a MIPI. You can list all these. Yeah, that's part of your daily business. But we made a list and we talked to our customers what is needed again and again and again to start this kind of modularization. And in the middle of the unit, you have processing power. You have an FPGA, different kinds of, but it's the same. It's an FPGA, it's power management. So we just took a piece of paper and wrote it down. Next level, of course, when we know that we need these modules again and again and again, we said, okay, why not take the bill of material, the schematics and the layout to be repeatable, to build building blocks that reuse your parts. So an interface like MIPI, you have a connector, of course, and depending on the functionality, you have some other components. But the tendency, it's the same. It's every time the same components. So you have the bill of material repeating the schematics and the layout. And then it looks like this. You can define with your customer the system that he wants to build up, and he can build like Lego blocks. You can take the different blocks and set up your system to see what is needed. And you see on the right side the layout, it's the same. Yeah. And even the components are the same. And as we produce the electronics, we have these components in stock. So when you go through a whole process of engineering and producing the PCBs, there's a lot of aspects that you can coordinate to streamline it and to build in a rapid succession these kind of repeating, more or less similar video units. That's the graphical visualization that one of our graphics guy did. We call that fast lane. So everything that I talked about, the modularization, the repeating tasks, and the kind of idea to make it like building with Lego, to have all these modules and to reuse them, and then to speed up. That's how we present it to our customers, or I present it today to you, to say, okay, it looks like this. Most of the points might be known to you, or you have the same ideas. So the difference is that we began 5 years ago to build the company around these kind of processes. So we defined our processes to handle this fast lane aspect. Again, it's not magic. Yeah, it's just thinking, sit down, think, what do we do and how can we do it better and faster? Because there are tons of good engineers in the world. Our engineers are not better than the engineers at our customers. Yeah? But when we can help them to speed up their projects, they have a realistic chance to be number one as innovator in the market. So it's time. Yeah? Of course, a lot of people can engineer it, but if you find ways to make it faster, it really gets interesting. So on the one hand, we have to handle the growing complexity. We have engineers that we get from university. They don't have 10 or 20 years experience and can do that even while sleeping. So when we can modularize it, we can give it to new engineers, new people that can join our task forces. We can give them a system that they can use with less experience than before. Design risks are minimized. Time to market, that's what I said about. And the modularity. Because when you build a carrier card and use a system on module, FPGA module, or a GPU with like NVIDIA Jetson, you can exchange them. You can make hardware upgradable. And you can even take the carrier card out of the system. You have 6, 8, 10 weeks to redesign the carrier card. Then you can make even the carrier card upgradable in the process, while engineering, or even when the project is out at your customers. So the modularity helps a lot when you turn the company, the processes around and streamline it according to these processes that are needed. So A and B. A, you can advance engineering because you can take these cards, start engineering on day one. You have a hardware that is industrial grade level. You don't have to take evaluation kit from the companies, but you have an industrial level video card and you can start engineering. And because you have the same FPGA like your serial product, the software people can begin from day one to build their software on a serial near FPGA platform. Number B, option B is you don't take the existing card, but you take the 6, 8 to 10 weeks to build your own prototype hardware in that early stage. So there are different ways, or even more, I think there are more options to use this kind of platform to speed up engineering, especially in the beginning, and to be way more flexible during the design process, because you can iterate embedded hardware much, much faster, and you have several steps, and you can go into testing, serial testing, much earlier, and test your system and make changes, so you don't have to wait 4 to 6 months for the new PCB. That makes the difference in our point of view and with our experience. So, come to the end. What was important for me to tell you about our experience and the ideas that we got from discussions with our customers, from project experience, and the ideas, maybe similar ideas like you have, and how we turned the company around to make it real, to act like this. And that is the thing that I want to present you, how the company should change, not only have the ideas, but how you have to push them through to the whole company, from design to production to engineering, and to the people and the heads and who build the strategy, and to change this. So that is the idea. What we say, we effectively support our customers in being tomorrow's world market leaders. And the focus today for my discussion was effectively speed up, make it easier and faster. And maybe there is a little bit of HEMA Visioneer spirit inside of your new project. Maybe we can support you. I hope there will be some discussions afterwards. I think my time is over, and we have time for questions right now. Thanks for your time.
Thank you, Oliver. I could allow one question. Is there a question from the audience? Yeah?
Thanks very much. Very insightful presentation. I was wondering how you sort of add the idea of design for manufacturing in this rapid prototyping that you were now emphasizing on.
Design for manufacturing was...
For higher volume. So once you go then beyond those 25, 30 days, which is your sort of your development cycle, once you need to truly scale up in order to have costs down and higher volumes, yield, and all these considerations, where in this equation sort of this factors in? Okay, so when at the beginning you have only prototype status, so you need some of them. And if the idea is really good, we have to scale up. So at first, at the beginning, it doesn't make a big difference, because we can take the platform and start programming, start engineering. And then depending on these first prototypes and the engineering and testing, and sending your salespeople out there to present it, yeah, then you get a market feedback in what kind of application we can go and what numbers do we get. And then we can go into several directions. Of course, we have a low volume, high power application, so we can ramp up, we can exchange the system and module FPGA to have a more expensive, but of course more powerful version. And we can shrink down the components, so we can exchange the components in a next design run to scale down on, of course, the expensive components like the FPGA. We take a smaller one. Or if we go in high volumes, we can go into a design in. Then we just shrink it down and buy less expensive components like connectors. Yeah. Connectors are very valuable components, and the FPGA is important. And then we can iterate down from this status of working prototype. Yeah. And of course, if we manage to stick more or less to the same components, we have a same component strategy, what makes it easy to build and manufacture the high volume, low cost, and the high volume with more or less the same components, so we profit from the high volume and the low volume, and we can build a kind of family of products that have different applications and different cost factors. That's the idea that follows afterwards. Yeah. Thanks for the question.